Hello everyone, Assalamu alaikum. My name is Adnan Shakib and I like to represent a voting system using full adder and parallel binary adder. And this is our fellow members, Jyotimoy Sarkar Shubho, Mahamudud Shami Mahi and MD Nure Alo. Let me introduce the system. Voting system usually full adder and a parallel binary adder used for determined option and voting for issues. Simulation proved number for yes and no votes can be applied in groups settings. The main goal of this project is to build a voting system, utilize full adder and parallel binary adder for real-time determination of yes and no votes within an assembly. The system architecture involves switch representing yes or no option at each other assembly option and displayed to indicate the respective vote counts. Yes, a diagram is represented for six setup cycle to admitted longer assembly through additional models and parallel adder and display circuit. The overview. An example of a full adder and parallel adder application is a simple voting system that can be used to simulation provide the number of yes votes and the number of no votes. This type of system can be used where a group people of assembly that there is a need of immediately determination option for or against making decision or voting for certain issues or other matters.
Everyone, today I am excited to introduce to you the apparatus we will be using for our voting system demonstration. Our setup includes essential components such as 5-volt power source to provide the necessary electricity, connecting wires to establish connection between different elements, resistor to manage current flow, LED for visual feedback, and crucial integrated circuit, especially IC7483 and IC7447. Additionally, we have common anode 7-segment display which will serve a visual output for our voting system. Together, these components form the backbone of our innovative approach to voting system. Now I am thrilled to shed some light onto the role of IC7483 in our voting system. This integrated circuit is a key player in our setup as it serves a full adder, a fundamental building block in digital automatic circuit. With its ability to perform addition operation on binary numbers, IC7483 plays a crucial role in trailing votes and calculating totals. Its effective design and reliable performance makes it indispensable compared to other voting systems, ensuring accurate and swift computation and voting results. As we explore further, we will see firsthand how. After that, I am excited to discuss to you about the specific configuration of IC7447 in our voting system. This integrated circuit is a specialized component known as BCD to a 7-segment decoder or driver. What that does mean for our voting system? Well, IC7447 is responsible for converting binary code decimal output for arithmetic operation into signal that can be displayed on our anode 7-segment display. In simple terms, it translates the numerical data in a formal format that is easily readable and interpretable by users. Without IC7447, our voting system would lack the vital link between computation and visual representation. Another Vital component is the common anode 7 segment display. This display technology is widely used for its simplicity and effectiveness in conveying numerical information. Each segment of the display can be individually activated, represent different numerical digits, making it ideal for showcasing voting results and other numerical data. With this clear and conscious presentation, the common anode 77 display provide user with the instant visual feedback, ensuring transparency, accessibility in our voting process. Let's explore how the display exchanges our expressions and functionality seamlessly. Now we will see our simulation, multi-simulation, and now we'll see our multi-sim simulation. Now I like to show you our simulation. This is our simulation. As you can see, there are 3 7483 IC and 1 7447 IC, and in that 7447 IC there is a 7-segment display attached. We used 6 switches to represent 6 votes. If the switch is on, one switch is on, it will count as 1 vote. You can see from the simulation that 3 switches are on, so the 7-segment display shows 3 votes. Now if we continue to the next slide, there are 5 switches are connected. Now it shows the 7-segment display shows 5 votes. Hello again. This is our hardware implementation. This slide was supposed to be represented by our group member MD Nura Alam, but unfortunately because of poor health he couldn't attend our presentation, so I will continue the hardware implementation on behalf of Nura. As you can see, we have successfully made the voting system. We followed the simulation and made exact replica in real life. You can see from the pictures that it successfully shows the votes, but it shows up to 6 because there are only 6 switches. The voting system we made is very simple. It includes switches for yes and no vote selection at each position. It has a 7-segment display to show how many yes or no votes, and it can only show 6 votes, but it can be extended to any number of positions by increasing the switches and adding more IC.
Assalamu alaikum. Let's talk about advantage. One advantage of using full adders and parallel binary adders in a voting system is the ability to process multiple votes simultaneously, since each candidate's votes are represented in binary and in parallel. The system can tally the votes quickly and efficiently, reducing the time needed for counting. Additionally, the binary representation allows for easy integration with digital systems, enabling automated counting and result reporting. Now, the limitation of this project. One limitation of using full adders and parallel binary adders in voting system is the complexity of the hardware required. Implementing such a system would involve designing and building sophisticated electronic circuits, and which could be costly and time consuming. Additionally, ensuring the accuracy and security of the system would be crucial, as any errors or vulnerability could compromise the integrity of the voting process. Furthermore, it would be easily scalable for election with a large number of candidates, high volume votes. Now the conclusion part. Full adders and parallel binary adders are used in voting system to efficiently tally votes. Each candidate is assigned a binary value and the parallel binary address sum up the votes in parallel, speeding to the process. This approach offers advantages like simultaneous processing and integration with digital system, but requires complex hardware design and security consideration. Stability may also be a concern for larger elections. That's all.